I don't know if I should be David Attenborough or if I should go with Steve Irwin, like, crikey, look, it's a over there. Or if I should be like, in the wild, derivatives. No, that's a bad David Attenborough. Doesn't matter or mind. Nobody cares. Day one, crikey. Derivative math that I have explored. All right, so I started off thinking, remembering that there was an equation that I hated. I thought it was tedious. I didn't understand it at the time. And then when I learned how to make derivatives later, I was like, why did we do that super long way? So I Googled what I remembered from it, which was f of x plus h. And the internet knew what I wanted. And what I wanted was the difference quotient. That's what it's called. And here's the equation. So the limit as h approaches zero. Come on, do your magic. There we go. Here is the thing. The limit as h approaches zero of f of x plus h minus f of x over h. Now, here's what I did not understand at the time, is that equation explains a secant line going through a curve, right? So we've got a curve here. I'm drawing this as we're talking. I'm drawing a parabola, and we've got a secant going through. So this dot here would be at x comma f of x, and this would be at x plus h comma f of x plus h. And so as the secant approaches zero, it becomes the tangent. And as I said in my previous video, tangent line is the derivative to a curve. So we are figuring things out. This, though, confused me very much. It says, we know that the derivative of a function f of x is nothing but the slope of the tangent. And I thought, it's nothing but that? That's the only thing it is? I just feel like there's so many applications and there's so much that is complex about calculus that, like, it's the derivative is only the tangent. And then what about derivatives to a higher power? I can only really consider a tangent line to like a x squared, right? Like that makes sense to me, or like a tangent line to a circle. But like area under a curve, that's calculus. We have to do derivatives for that. I just thought, is nothing but the slope of a tangent line, just felt minimizing. And also, I'm not sure how accurate that is. That's the only thing it is. I don't totally believe that. Feels like that is oversimplifying. And then I have this other quote from my journey today. Calculus is a branch of mathematics that studies rates of change. That I did find helpful. Yeah, that's what we have going on here. How are things changing at any instantaneous moment? And also, as I was going through and figuring out about the difference quotient equation, I was wondering if I needed to study limits. And I feel like maybe not. How much of the limits do I need to remember to understand derivatives? That is another question that has come up in this. And then every time I talk about limits, I quote Mean Girls because I literally cannot stop myself. The limit does not exist. The limit does not exist, right? That was my Katie Heron. The limit does not exist. That's the only correct answer. So, in summation, today I explored the difference quotient equation, and the explanation of that I found very helpful. And here actually this is in the pre-calculus book, which I do tutor from time to time. This set of graphs that shows the secant line getting closer and closer and closer to the tangent line. So that is why we say as h approaches zero, because if h approaches zero, then then it's going through this point right here, like this, the line. If this is h, This is h, is the difference between here and here. As h approaches 0, it gets back to that point. So that is how that secant line becomes the tangent line, because at 0, it is at the tangent point. And the tangent to the curve is the derivative. And that is something that I know, but also still feel confused about. So those were the things that I learned today. Thank you for tuning in.